Hi everyone. So I'm going to explain what are you going to draw for this lab, gravity lab. So you know that gravitational force is given by this formula where you have gravitational constant shown with the capital G is 6.67 times 10 to the minus 11 Newton meter square over kilogram square. So this is the accepted value of the gravitational constant. Okay, so I want you to find an experimental value for this constant. That's why you need to draw the graph of force of gravity versus this parameter that I asked you to calculate on one of the table in the lab activity. So if you look at this formula, you can maybe see the similarity between this and the linear equation in algebra. Linear equation between y and x variables are given as y is equal mx plus b. Here b is basically a constant that we can ignore and take it as 0. So y in this formula we have is force, m corresponds to gravitational constant, and x corresponds to our parameter that you calculated, m1 times m2 divided by distance squared. Okay, so in linear equation, m corresponds to slope in equation, where the slope of graph found from when you put y in the y-axis, the vertical axis, x in the x-axis, which is the horizontal axis, right? So when you draw a graph of a linear equation, you get this straight line, and the slope of it can be shown on the graph as equation on chart, which I explained in Unit 2 under Weekly Guide. If you go to Unit 2, graphing is explained there in several videos. So if you don't remember the details, please go to Unit 2 under Weekly Guide in the lecture section, okay? And watch those videos for graphing, because you will need to draw a graph here. So here your y is the force. So you're going to draw force versus this parameter here, okay? So your force is your y, this parameter is your x, therefore your g, the constant, gravitational constant, corresponds to the slope, okay? The slope here is going to be found from the equation you will draw. So again, your y here is going to be your force of gravity. Your x is going to be your m1 times m2 divided by d squared. These values are calculated in a table, so you know these values. Therefore, when you go to an Excel sheet or Google Doc, what you will need to do is, again, I don't want handwritten and drawn graphs. I want them to be either Microsoft Excel or Google Doc. And again, those videos under Unit 2 shows you how to do that. An Excel sheet or Google Doc, again, they work pretty much the same way. I tried them and I can say like it's exactly the same. So when you want to draw force versus this value or whatever the graph that you want to actually draw, y versus x, y always goes to vertical line and x always goes to horizontal line. So in this case, your y is force, your x is this parameter. So what you need to do is in the Excel sheet, I'm sorry I cannot go there because this screen capture doesn't really let me move between different windows and different tabs and different apps. So here you have an Excel sheet. The first thing, the first one you need to enter is these values that you calculated in the lab, you enter them here. Okay, so it's going to be like, I don't know, I don't remember the numbers, like 100, 200, 2000, 5000. I don't remember the numbers really, 300. So the first column is going to be this values where your x-axis is going to be. And the second column is going to be your y values, which are your force values. For the force values, you will need to enter an exponent. And in Excel, the easiest way to enter an exponent value is, let's say you have 1.2 times 10 to the minus 5. How do we enter this in the Excel sheet? It is 1.2 capital E minus 5. Okay, this is how you enter an exponent in the Excel sheet. So this is how you need to translate that value that you read or enter into the LOB table into an Excel sheet data. And then you will basically draw y versus x, which is force versus m1, m2 divided by d squared. And the slope in this case is going to be, as I said, your gravitational constant. So it's going to be very close to this number, hopefully, if your data is good. It's going to be very close, but I'm expecting you to have some errors. And therefore, I want you to calculate your percent error. How do you find a percent error? In any case, in any lab or experiment or data analysis, you will need to calculate percent error. So it's good to know how to calculate percent error. In any case, the percent error of any given parameter is accepted value of that parameter. Let me just erase this part. Minus experimental value of that parameter. Divided by accepted value, again, times hundreds. Okay, so the accepted value, as I said, is this value I gave you in the question, which is 6.67 10 to the minus 11. The experimental value is going to be coming from the slope of your graph. Okay, so the experimental value of G, the gravitational constant, is going to be the slope. Therefore, you need to show equation on chart of your graph. From equation on chart, you can read what is the M value, what is the slope. And again, if you forget these details, please go back to Unit 2, watch the videos again about graphing, and see how you show equation on chart. And please give me an acceptable graph and percent calculation. I can accept percent calculation on paper, however, I will not accept hand-drawn graphs, that's for sure. Please attach your graphs and percent error calculation on the lab, and I will grade them by hand, so make sure that you attach them in all of your trials. I hope this helps, and if you have a question, don't hesitate to ask me through email. Bye-bye.